In this video, we're going to talk about simplifying factorial expressions. As a review, if n is a natural number, so n belongs to the set n we spoke about in the previous video, and the set n is the numbers 1, 2, 3, 4, so the set of natural numbers, you need to know the following. If we have n and I want the next term, I must add 1, so I get n plus 1. If I want the next one, I add 1, I get n plus 1 plus 1, which is n plus 2. And we can keep going till we get infinitely many natural numbers in terms of n. Now if I want the preceding one, so I must subtract 1, we can get n minus 1. We can subtract 1 again, and we get n minus 2, which is preceding to n minus 1. And so on. We keep going till we reach 1 at the end. Now, knowing these, if you're asked to simplify or evaluate the following expression, so let's say we have 3 factorial over 3 factorial times 27 factorial. And you're asked to do this without calculator and simplify it. Now, some students, they tend to go back to the definition of factorial and write 30 as 1 times 2 times 3, so the product of the first 30 natural numbers. So they start by doing the following. And they expand the 3 factorial, the 27 factorial, and the denominator and try to simplify. However, there is a quick way to think about this question by doing the following. I always look at the largest number I see in the expression, and in this case it's 30, and I look at the second largest number I see, which is 27. As we said before, we can rewrite any factorial of a number in terms of factorial of a smaller number. So the 30 factorial basically is 1 multiplied by 2 by 3. We keep going, and I have 26, 27, 28, 29, and 30. Now if I decide to take from 1 to 27, then I can rewrite 30 factorial as 27 factorial, and I still have 28 times 29 times 30. So we're going to use this trick. Always you are allowed to do the following. So by looking at the largest and the second largest, then you can rewrite 30 factorial using the second largest number you see in the expression. So you can write it as 27 factorial, and we keep going by adding 1 each time to the 27 till we reach the number 30 that we have at the beginning. Alright, so 27, then we need 28, we add one more 1, we get 29 till we reach 30. I stop there. To the denominator, keep it the same. And as you can notice, we have 27 factorial, 27 factorial. We can simplify. So we're left with 28 multiplied by 29 multiplied by 30 over 3 factorial, which is 1 multiplied by 2 and by 3. Now I check here, can I simplify? Yes, I notice we have 2 and 28. So divide by 2 by 2. Here we get 1 when you divide 2 by 2, and 28 divided by 2 you get 14. Can we simplify more? Yes, I see 3 and 30. So 3 divided by 3 we get 1. 30 divided by 3 we get 10. Now we're left on top with 14 multiplied by 29 multiplied by 10, and in the denominator we have 1, so anything over 1 stays the same. Your final step is for sure to multiply 29 and 14. So 4 multiplied by 9 is 36. 4 multiplied by 2 is 8. Plus 3 we get 11. Then we cross the 4, we write a 0. Then 1 times 9 will be 9. 1 times 2 is 2. We add and we get 6 plus 0 is 6. 1 plus 9 is 10. So 0 and 1 on top. 1 plus 1 is 2. Plus 2 we get 406. So basically we got 406 multiplied by 10. And our final answer will be 4060. Now, different example. If you're asked to do the following: n plus 3 factorial divided by 4 factorial multiplied by n plus 1 factorial. So n plus 3 factorial, it's the natural number that comes after n plus 2. Now comparing these numbers, if we go back to this one here, we can notice that n plus 3 is the largest, and the second largest will be n plus 1. Now, any number you see with factorial notation, and we have expressions like n plus 3, n plus 1, the number or the integer by itself is the smallest. So we still have n plus 3, n plus 1 to compare. N plus 3 is larger than n plus 1, so we're going to rewrite this expression using the second largest number we see. And in this case, we're going to rewrite n plus 3 in terms of n plus 1, as we said before. So I write n plus 1 factorial, and I keep adding 1 till we reach n plus 3. So after n plus 1 we have n plus 2, and I need one more, so add 1 to reach n plus 3. So I'm done with the numerator. I go back to the denominator, keep it the same, and as you can see we have n plus 1 factorial, n plus 1 factorial are the same. We cancel them out and we still have n plus 2 on top multiplied by n plus 3 over 4 factorial. Now, either you keep 4 factorial the same, or if we want a number, then I know it's the product of the first 4 natural numbers, 1 multiplied by 2, by 3, and by 4. So my final answer will be n plus 2 multiplied by n plus 3 over 2 times 3, which is 6, times 4 will be over 24. And this is our simplest form. For sure, if we want expanded numerator, we need to distribute the n plus 2 over n plus 3. I hope this was clear, and we're gonna do more questions in the next video.